So tell me, what do you understand by microservices? So microservice is basically decoupling of entire application into small services. Okay, like if I take an example of Amazon or Uber, or like you can say any application. So like take example of Amazon. Okay, so in Amazon we'll have like many partners like seller, then we'll have buyers, and at the end we'll have like persons from Amazon who will be managing all the applications, or like who will be seeing the transactions and every other details. So we'll mention it as an admin. So this is an entire application. Say suppose it is written in Java. So what happens is, like if I need to change something, like in buyer I need to change a small, like I want to give an offer of 5%. So what I need to do, I need to write the code and deploy the entire application. So instead of this, we can use microservice based architecture, where the seller will be a single application, buyer will be another application, and the admin would be another application. So here what happens is, like if the admin is down, or like if the server is down, the entire Amazon website is down. So but in this case, if admin is down, people can use the buyer option, or like if this seller is down, seller will not be able to add any further items to his store, but the buyer can able to check out from his cart, and or he can add anything from other sellers or which are already in the stores. And if suppose I want to change something in seller, like I want to deploy, so I just will go and deploy this application. And the seller, what happen is, like it may be written in Java, it may be written in .NET, it may be written in Node.js. So you said that it is a decoupled architecture. So coming to that, can you explain what are the major differences between service-oriented architecture, monolithic application, and a microservice? So what happened is, like as I already told, that in service-oriented architecture or monolithic application, it is the entire application. So the application, monolithic application, is the whole block of application. Service layer or SOA, service oriented architecture, is like we define small module but inside the same application only. So we make it modular wise, like we take the part of if we take the example of Java, we created packages, we create interface for particularly for DAO layer, particularly for seller, particularly for customer, and particularly for admin. And in microservice, what we have is, like we'll have more granular levels of breakdowns. Like in seller also, we can have different types of sellers, like from US we can have the part for US only, which will be running on any servers on US, or we can have clients or any other applications who will be interacting with, or auth layer for particularly sellers and auth layer for particularly admin. Two different applications we can have. So all these are completely segregated and talk to each other in like over an HTTP and not through the application himself. So if I draw an example, you can tell like monolithic, SOA, and if I take the example of microservice, I can say like microservice and there can be n number of microservices. Okay, now I will give you two scenarios. First, design a simple microservice architecture application. And the second scenario is migrate the existing monolithic application to microservices, and what will be your approach, or what will be your thought process to break down those into small microservices. Like you took an example of Amazon, right? So you can just show how Amazon can or if you are a owner of Amazon that particular software, so how would you would have broken it into small microservices. So how I'll design a microservice is like, if it is a new application, as you already told, since it is a new application, so I'll just take the requirements. So I'll ask like, who are the users, what are the existing, means how the relationships are mapped, what are the dependencies, you can have like buyers and sellers, so both are actually correlated, we can't segregate it out completely. So the database, how we'll manage the databases and all. So if I take example of buyer and seller only, so buyer will have its own name, ID, and like items. So we have 3 tables, and seller will have like cart details and items brought. So these are different tables. So this item and these items is related, so it is like, it can't be like I have brought here like a pen and the buyer doesn't sell a pen, or any of the buyers doesn't sell any pen. So it is related. So how I'll interact is like, I will call this, and suppose he brought already one item or added it, so it will get deleted from here and it will be added here. So this is how, but these things are completely independent, these are completely independent. So we can keep it out and build 2 microservices, microservice 1 and microservice 2. Yeah, this is how generally we define microservices for if I am going for a new application. Say it is database, and this is database. And how we'll break a microservice, actually this is a long-term process, it doesn't work so quickly or so nicely. So what we can do is like, in monolithic application, there we need to change the existing application also side by side, and there are microservices. So suppose we have buyer, seller, and we want to take this out and make it as a microservice. So what we can do is like, instead of buyer calling this, we need to have like a mechanism to call an API. So admin will also be there residing, an API for admin also, and it will point to this microservice. So we'll build this microservice, we'll take this part, this business logic from here and put it here, and once it is done, then we'll just point it out. Instead of calling this, we'll now call this, and instead of calling this, we'll now call this. So this is how we break down. So we need to take care of similarly the table structure, the schema, and we need to slowly and gradually we need to take these and map. So it's like a long-term process. So while breaking those microservices, what are the advantages you have and what are the drawbacks while using all this microservice based architecture? So the main advantages of microservice is like, earlier I told that we'll deploy. Okay. So how we'll define is like, we have buyer, then we have seller, and we have admin. So like independently we can deploy, independently we can make the code change. So it's fault tolerant. Like if it goes down, it will be up, it will be up. Then what else? Oh, one more thing is like, we can expand it, like we can scale it. So like independently we can have entire admin, then admin, and we can have a load balancer to navigate the traffic. And one more thing is like, as means it's mainly practiced by Netflix, so like an individual contributor or an individual developer will take like the requirement, then he will deploy it, he will make the code changes, then he will deploy it in like cloud or any server independently. So he takes the complete responsibility because it's a small task. And one more thing is like, it can be written in Java, it can be written in Node.js. So there is no like dependency on any particular technology, so anyone can use any technology. This is the main criteria. So the main problem is like, we can have multiple layers of authentications, like microservice 1 is talking to microservice 2, microservice 3, then it is talking to individually, they are talking with each other, then microservice 4, then microservice 5. And suppose like so first of all, we need to have individual deployment strategy for each one. And suppose if something goes failed here, so we need to find out, and we need to find the root cause or why it got failed. So we need to debug all the stages here, and why it got failed we need to check. And on the top of that, we need to have multiple layers of authentication. So for microservice 3, it may able to access few of the applications or few of the API. So this one will give like auth, this one may have authorization type 2, so here we need to implement multiple types of authorization, means like for each one individual applications we need to give multiple layers of authentications or authorizations. So you have hierarchical of microservices, like microservice 1 and microservice 2 is talking to microservice 3, suppose, which is an auth layer, and then microservice 3 is talking to some other microservices like 4 and 5 respectively. So if something goes wrong, like in microservice layer 3rd or layer 4 something went wrong, so how you will know that that microservice is failing, and you need to debug that microservice application logs. So to answer your question, suppose I have multiple layers of microservices. So what we can do is like, we can traffic all the logs to Splunk or Kibana, or we can say Elasticsearch, and for each request we can generate a correlation ID. So this correlation ID will be passed through each of the headers, and it will be logged in the Splunk or like Elasticsearch. And like, suppose if anything goes wrong with this request, so we can later take out that request and see, okay, how we can process it from the back end. So that's how. And if something, suppose this server went down, so we can have a health check to look for all the servers. And suppose if this went down, the health check will return to the Kibana or email notification, like that we can have. Okay, can you tell me some of the best practices of microservices? So best practice, there are many things, like first we can Dockerize it. So it is not mandatory, but we can just Dockerize it. So I worked in 3 of the projects. So in one I used serverless SLS technology for deployment. In other application Java, we just Dockerized it. We took the image, made our own image, and we deployed it in Amazon Cloud Computing. So there is separate build for each application. So each application, like microservice 1 is built and it goes into deployment through Jenkins. Microservice 2 can use TFS instead of Git, and it can be built like with Node.js and any other application, and it can be deployed in Amazon Cloud. Microservice 3 can be deployed it in Amazon, or not in Amazon, suppose Azure Cloud or like Google Cloud. So means individual build mechanism or methodology is implemented for each of the microservices. And one more best practice is to, like, for each microservice, instead of talking to like microservice 1, microservice 2 and microservice 3, instead of talking to database 1, a single database, what we can do is, like, we can take this out and make individual databases. So while deploying those microservices, what are the technology stacks you mainly use? So setting your technology stacks, I already explained like how microservice works. So it's like individuals contributor, or it's like a particular team decides like whatever technology they want to use. One microservice can be on Node.js, one microservice can be on like Java, okay, then PHP. But the main overhead is like we need to write the deployment script for each one, and so if I go with Node.js, then the deployment would be same, means if I am deploying it to Amazon cloud or any other cloud. Okay. And how you communicate between those microservices, and means like I don't want to give access to all the microservices so far. So means this will be my REST APIs, right? So it will be exposed like either in the VPN, virtual private network, or in means like publicly. So how I can restrict few peoples from accessing those microservices, or the few not peoples, I'll say like few applications, how I can restrict them from accessing the microservices. How they communicate using normally HTTPS or HTTP. So we use REST API to communicate between one microservice. So microservice 1 and microservice 2 will communicate using REST. So what happen is, like, suppose a buyer wants to get some of the information or the items available or not, so he can check from the seller side, and using get API he can get it. But once he brought it, like he already added it in cart and he checked out, then what the buyer can call for a means like put API to remove this, or like soft delete the item. So should it be like stateless? Yeah, it's all the APIs are always stateless. Okay. Why stateless? Because like inside elastic load balancer or load balancer, you can say similar type of microservice can be there. Microservice 1 type, there can be like n number. So like request came, I want to preserve it, so I will not preserve it, because what will happen is, like for request 1, suppose I'm trying to get this request, get the item, so it is served by this microservice item. Then again when it comes, if I am preserving this in this only, the next request for the put, it may come to this or this, so this will not be handled. So for this we will make it stateless. So how we will do authentication is, like we will have multiple layers of like microservices. Sorry, it will be one. We can have elastic load balancer or application load balancer. And so for authentication or like preserving the session, we can use like Redis or like any cache mechanism, and each one will talk. So this one will be single point of contact, so this one will all be stateless. So how a user interface or a client interact with the first microservice layer, like I have a user interface or a browser, how I'll interact with the microservices. So how a user communicate with the microservice is, like suppose we can have a client or a browser, and here we have amazon.com. So using like CDN, content delivery network, we can get the photos, and like static pages. So this JavaScript will communicate using REST API to multiple applications. So from here it will fan out and it will go to like microservice 1, microservice 2, microservice 1, and then from here onwards it can communicate as usual like microservice 4, microservice 4, microservice 5. They can internally correlated, and then we have our databases. So that's all for this tutorial. Don't forget to hit the subscribe button. If you have any question, then mention in the comment section. Or if you want me to make interview questions like this on other technologies like Java, Node.js, Amazon Cloud, then do let me know in the comment section. And from both of us, don't forget to subscribe. Hit the like button.